So, MediatR wants your money now. Yep, it's going commercial. But before you panic, or even worse, start paying, let me show you how to build your own clean, fast, and CQRS-ready MediatR for free. We are talking a full replacement, custom handlers, clean architecture, and the cherry on top, source generators to automate everything. By the end of this video, you will have a fully working MediatR alternative, one that scales, performs, and doesn't cost you a cent. And trust me, it's faster than you think. Okay, quick refresher. What is the MediatR pattern? And why do people love the MediatR package? This is basically what a MediatR is. The MediatR helps decouple your objects. So instead of component A calling component B, both will go through a central messenger, MediatR. Now in .NET, the package MediatR is the go-to basically when you need to implement the CQRS pattern. And CQRS is command query responsibility segregation. So in CQRS, the user will decide to query either by calling a query, that's basically a query handler, read from the database and return the data, or either if the user wants to do some writes on the database, they will perform a command, the command handler will perform the action, and we write to the database. Here, MediatR, the package, will help us facilitate the way to use queries and commands by calling the respective handlers. So here's the plan. We are going to build our own MediatR with CQRS in mind, and we will do it step by step. Okay, so first, let's create our interfaces. We are going to begin by creating a new folder. I'm going to create the folder CQRS. Inside that folder, I'm going to create my first interface, which is the query. I'm going to have a folder queries. And then inside of it, I will have the interface iQuery. Okay, this is my interface. The query should be a generic, and we need to return something. So it will be an out of T. We can add some constraint. We can add a where condition that T is a class, but yeah, for now, let's keep it simple. It will allow anything. So we can, even the primitive types, we can return them from a query like string or int or something like that. So this is my query, and I'm going to have an interface iQuery handler that accept a T query, and it will return a T result. We can do a condition here that T query is iQuery of T result. And in my query handler interface, I will have one method, which is task of T result, handle async, T query query. We can also add support for cancellation token like this. Let me move this to a separate file. Okay, so I have my query and my query handler. Now, let's create our commands. Same thing. We'll have a folder called commands. Inside of it, I will have an interface iCommand. Same as the query, iCommand can return a type, and we can have the interface iCommand handler that accept T command and return T result, where T command is iCommand. The command handler also will have the same thing, T result, the command, and let's support cancellation token as well. And let's move this into a new file like this. Perfect. So now we have commands and queries. Let's bring it to life. Let's create our first command or query. Let's create our own feature now. So for that, I'm gonna keep the feature slicing, the vertical slicing, by creating a new folder called features. And inside of it, I'm gonna first create a new record, which is create user command. So I need to create a user. It will be iCommand of quit. So basically, let's import the namespace of commands, and this is our record. We can have here string username and maybe an email. Okay, and now I can create the class create user command handler that implement the interface I command handler. Let's implement the missing members, which is the handle async. For now, I'm gonna just keep it simple and inject iLogger and just log that we are creating a user. So I can do logger.loginfo. Let's make sure that it's a structured log, and here we can have command.username. Because it is a task, we can either return task from result, or the way I like it to be cleaner, I can do await task.yield, and we can mark our method as async. And then let's return a new GUID, something like this. So we are creating a new user in the database, let's say, and this is the ID generated. So this is our command. Let's also create another feature, which is get user query. Let's make it record, and let's have a good user ID. It is iQuery of, we need a response. So let's say user response. And here we can have also another record, GUID ID, username and email. And here let's implement the get user query handler that implement iQuery handler of get user query. This is our query and this is the response of that query. Okay, let's implement handle async method. First do task.yield. And I can return new user response. Let's say this is the query, the parameter query dot user ID. As an ID, I can have a username, my user, and my @email.com, something like this. Okay. Now let's create APIs to use this command and query. Okay. So go to program.cs. First, let's register our query and handlers. We need to do builder.services.addScoped. We need to register iCommand handler of create user command with a return type of GUID to return the create user command handler. And we need another one for the query. So builder.services.addScoped. We need iQuery handler of get user query to return user response and to be registered as get user query handler. So we have now registration for both command and query handlers. If you ever manually register like 10 plus services or handlers, you know how things will get messy here. Let me know in the comment below, how are you configuring your registration? All right, we got our command, we got our query, we got our handlers, and we registered them. Let's expose them now inside an API. I'm gonna use minimal API for that. So here in the web application, I can do app.mapPost, and the route will be users. It is an async, yes, but for now, I'm gonna keep it empty like this. And what do we need here? We need to accept in our body, in our request, a create user command, the command, and we can inject our command handler of create user command, the handler. We can also inject cancellation token. And then I can simply do handler. I can do await handler.handle async, the command, async, and var user ID equal, because our command handler will return a GUID, because this is how the definition of a command. And this user ID can be used to return results.ok new user ID. Okay, this is our endpoint. Notice here there is no black magic. We are injecting the command handler. There is no mediator running this. This is purely CQRS implementation. Let's go to our API test and let's actually test our API. So we need post, let's say create user, and the content type needs to be application JSON. We need username. Let's call it Book. And we have an email. Let's be info@amdbook.com. This is our API. I can now run the project. I can do a post not found because we need to specify users like this. Now, call it again. You will see that the API is returning 200 OK with the user ID. So our CQRS implementation is working, our command is running, and the handler is handling our command. I'm gonna do another endpoint for map get so we can get a user by ID. So let's do app.map get with a route of user/ID. It is async also. It will accept the ID as a GUID, and we need to have query handler of get user query returning user response to the handler. We can also add cancellation token, but for now it's fine. And here we can do var response equal handler dot handle async the new query with the ID, and that's it. Here, notice, we need to await our task. The response now is a user response, and we can return results.ok of response. Now let's go to the API test and actually do create get user. It is a get users with an ID. It doesn't matter what is the ID, so we can do generate GUID, copy, and let's paste it here. This is our user that we are going to retrieve. Let's restart the application, run get user. You will see that we are returning the user. Okay, but let's be honest. How many handlers are you going to register manually before losing your mind? Let's try to do something else. Let's try to register our handler automatically. And for that, we can use the good old-fashioned reflection. But I'm not gonna write everything by hand. I'm gonna use Scrutor, which is a NuGet package that makes reflections from a DI super easy. So for that, let's manage NuGet and install Scrutor. Let's add that. So what we can do, comment the old registration. Let's stop the project. So I'm gonna comment the old registration and going to replace it with builder.services.scan. This is an extension method from Scrutor package. And here we can do scan. Let's do scan dot from assembly. I can do for now the assembly of program.cs, but you can specify multiple assemblies, and I will do add classes. So classes, and I need all the classes that is assignable to the type of query handler. Okay, as implemented interfaces with scoped lifetime. So same thing for command handler. So basically what we are doing here, search in our assembly for all the classes that implement iQuery handler, register them as scoped, which is very similar to what we did here. Okay, I'm gonna run the project and test, and things should be okay. Basically, there is no change except that we added some reflection behind the scene to register our handlers. So let's run. Let's try to create a user. It's working just fine. And let's do a get, and it's working also. So this works, but there is a runtime cost. Plus, you still don't get a compile time safety. Like if my query handler is missing, I can't tell unless I run the project and run the endpoint, and it will fail. So this is basically bad. But how to automate this? Well, spoiler alert, we are going to use source generators. Okay, perfect. So for now, we implemented CQRS commands, queries, and we are registering our handlers using reflection. But if you are using CQRS heavily, you will end up having a lot of handlers and a lot of commands and queries. If your application is only using CQRS, this is where you are going to need some mediator in the between to handle between a command and a command handler or query. So for that, we are going to create our own mediator class, which is what I like to call it a dispatcher. Okay, let's start by creating in that CQRS folder, let's create a new interface called iDispatcher. So this dispatcher will accept a command or query and route everything to their handlers. Let's start simple. I'm gonna add two methods, basically a task of tResult, query async tResult, accepting iQuery as a parameter, and let's do cancellation token. Another one is task of tResult, send async, accepting a I command of tResult. Very simple. Let's now create an implementation for this dispatcher. So public class dispatcher that implement iDispatcher. Implement the missing members, and that's it. So let's keep it very basic for now. I'm going to do a switch case, basically. Depending on the query or command that I'm receiving, return the handlers from dependency injection. First inject the I service provider. Okay, gonna call it provider. In the query async, we can do a switch case, which is basically a return query switch on the query. If it is, what do we have queries? We have get user query, Then we need to return await, okay, provider dot get required service of I query handler of get user query with the user response. Send await. So let's make it async here, and we can do dot handle async. We pass the get user query with the cancellation token. And if it is nothing, let's do throw new invalid operation exception, no handler found for the query. We just need to cast it as a tResult and as an object. We can do the same thing for the command. Basically, the command, we have a create user command like this. And same thing, we need to get the I command handler of create user command with a GUID. Let's make the method async, and here handle that command. Now, if we go to program.cs, we need first to register the dispatcher. So builder.services.add scoped. We need iDispatcher to be resolved as dispatcher. And we can go to the endpoints, remove the handlers, make it dispatcher like this, and change the code to send async. So basically dispatcher send the command, and here replace the query handler with iDispatcher of dispatcher. Same thing, query async, and we are going to test everything now. So let's run, go to the API test. Let's first create a user. It's created. Let's also get the user. We are getting a user. So look how clean are our endpoint now. One class, one interface we are injecting, which is the dispatcher, and everything is being handled there. Even though the dispatcher itself is yet to be refactored, it is ugly, but for now, it's doing what it needs to be done. And you don't need to inject any handlers anymore. Of course, switch statement here is not scalable. Imagine if you have 20 or 30 different commands and queries. This is too much. We need a way to resolve this dynamically, and we can use reflection, basically. Let me change first the command. I'm gonna comment. So first, let's get all the handlers that implement iCommand handler interface. So var handler type equal type of I command handler and make generic type true. I need that with type of T result. Okay, so far so good. Let's do var handler equal provider dot get required service of handler type. So now I'm resolving my handler using the handler type. So this is a type from iCommand handler that has the same type of the command and the same result from the T result that we have. So I have the handler. Let's create a new variable, which is the method that we need to execute. Var method equal handler type dot get method. Let's make it handle async like this. So we have the method now. I can now use it using reflection to actually execute it. So just to be safe, let's do a method. If method is null, we can throw new invalid operation exception, no handler found, fine. And I can do var task equal task of T result. Let's cast it to the task of T result and do method dot invoke the handler with an array of command and cancellation tokens. So let's use a collection here and like this. So basically what we are doing, using reflection, using this method, so we are calling handle async for the handler object, and we are passing the parameters for that method, which is using the order. We have a command and we have the cancellation token. So this is a task. We can easily say return await task. I can remove this one from here, and I'm going to copy things from here to the query itself, and let's change this to iQuery handler. This is a query. This is a query. Both have handle async. Both have a similar interface. And yeah, that's mainly it. Now, by the magic of reflection, we can run, go to the API test, and let's test. I'm gonna create a user. Nice, created. And I'm going to get the user, and nice, it's created. It's retrieved. And to show you the power of this, I'm going to create a new feature. Let's say assign user to role command. Okay, this will return, let's make it a record. And it is I command of, let's say, a string for now. Fine. Public class assigned user to role command handler. I command handler of assign user to role command with a string for now. Fine. And let's implement the interface. Handle async. I can simply do a return task dot from completed task, and we can say user is assigned to role like this. From result, sorry. It's from result. Even if the command doesn't have any parameter, it's fine. It just, I want to show you that by creating a command and creating the command handler and implementing the right interfaces, my project now will automatically, using Scrooter, it will register the new command handler, and our dispatcher will work easily by doing, let's go here, map post user slash roles, let's say. It is nothing, just the dispatcher. Its post doesn't accept anything for now. And let's do new assign user to role command like this. It will return the message, and let's return the message like this. Modify the API test. Let's run. We can execute the API and we have a message. So the dispatcher will automatically, using reflection, get everything that we need, which is very awesome. But it comes with a cost. Like there is runtime overhead, and like we said before, there is zero type safety. Let's be honest, we can do better. We are gone from manual to reflection, and now we are moving from reflection into automatic, but using source generators. Okay, first we need to create a new project. It needs to be a class library, net standard 2.0, and let's call it just mediate.generator. I do have a separate video for source generators, so I'm gonna keep the link somewhere here. Okay, so we created the source generator, and we need to make sure that we have a reference between our API project and the generator. But keep in mind, for source generator, we need the reference to have an output type to be analyzer and the reference output assembly to be false. So now let's go to let's delete class one and let's create our first generator. So the generator, what we need to do is scan all the interfaces, iCommand handler and iQuery handler, and emit a static mapping. Basically doing the ugly switch case for now. We need to create a new class. Let's call it dispatcher generator. Okay, let's do the stuff here. Allow nullable, implicit using, fine. And we need to have two packages to be included, which is microsoft.codeanalysis.c# and the analyzer. Okay. And you need to enforce the extended analyzer rule to be true. I'm going to use language version to latest just in case we used any language feature. And now let's save this one. Go to the dispatcher here. And let's do incremental generator like this. Implement the missing interface. And we need the attribute to be generator like this. Like we said, we need to get all the implementation of iQuery handler and iCommand handler. So this code here will get all the symbols for query handlers, implementing iQuery handlers and implementing iCommand handler. Okay, I'm not going to go deep into what I'm doing here. Check the other video. It will give you like a deep dive into generators in general. So basically here we are getting all the query handlers, all the command handlers from the project, and then we can start generating the actual text for the dispatcher CS file. So you do context.register source output, and we have now the source. We can start adding the text generated. I do like to add auto-generated as a tag in my first line in the class. So here I can add source dispatcher.g.cs, G as generated. So we can tell that this is a file generated by the source generator, and this is the text generated. If I save now and do a full build, this file should be created somewhere in if you go dependency.net 9 source generator, you will see now I have dispatcher.g.cs and we have auto-generated the comment that we added before. Nice. So now anything that I add here, it will be reflected to this file. And basically, because we are done from all the compilation, which is all the query handlers and command handlers, we are collecting all the symbols, we can start building the text that we need here. With the magic of editing, I'm going to show you the generated text. Okay, this is the generated text. It is the same thing, same namespace. I'm using class dispatcher here, and I have a private method that generate inside the switch case for each query case. Same thing for each command case. And if I go to the generated file, let's do a build. Yep, it's generated. We have a build error that we already have a same class with the same namespace, which is dispatcher. That's correct. Let's go to the class that we have before, and we can simply comment it out. Nice. It's commented now. You will notice now that inside the Sunday sync, we have multiple cases for each of the command that we have. Same thing for the query. We have also a case for this one. This is nice. Now there is no reflection basically to get things. Nice. And we can test everything by running the project now. Go to the test and let's create a user. It will be created, get, all the endpoint will work just fine. So our dispatcher is now using source generator. One thing that I would like to also do from source generator is basically to get rid of Scrooter and try to register my handlers automatically using source generator. So for that, I'm going to create a new source generator here, a new file. Here, I'm going through all the classes that implement command handler or query handler and actually create a new extension method called add mediator. And inside of it, you will notice now that I also added the registration of iDispatcher with the dispatcher class. So if we go back to the program here, if we go to the source generator, let's build, you will notice that there is a new file called CQRS generator. We have add mediator. We have all the commands and the query with the registration of dispatcher. So now I can remove Scrooter, go to the dispatcher, go to program.cs, remove this from here, and actually remove the registration of dispatcher and simply do builder.services.add mediator like this. If we go here, you will see this is the extension method that will register each command and query with the handler related to it. If we run the code, we should be able to have everything running as expected. You'll notice all the APIs are running as expected, and that's all being done with no reflection, and it's all being done through source generator. To recap, we are gone from manual dependency injection, then using reflection, using Scrooter, and then moving out of reflection, refactoring everything to use source generator. We also implemented CQRS purely with no mediator. Then we implemented the dispatcher class, which act as a mediator between the command and the handlers, query and the handler. And then we also refactored that dispatcher from a reflection-based into a source-generated class that generate everything for us. So I'm asking you, what do you want to see next? Should we go through the mediator package pipeline and behaviors? Should we do something similar using source generator? Let me know in the comment below what do you want to see next in this project, and I will catch you in the next one.